Good morning friends, welcome back to the class. In the previous lecture, we have discussed the introductory part of inverse trigonometry. Along with that, we also discussed the principal value of trigonometric functions, inverse trigonometric functions. Apart from that, now in this video, we are going to learn the various properties of inverse trigonometric function which are playing very important role in this chapter. See what we are going to learn today, that is properties of inverse trigonometric function. See friends, before proceeding further, I want to get clear you that in this video we are going to discuss only the formulas and their particular derivations along with their particular conditions. In the subsequent video, in the next video, we will discuss pattern wise questions. So I am dividing the entire lecture into 4 sessions. I repeat, I am dividing this entire lecture into 4 sessions. So please keep on watching these 4 videos in a sequence without fail to understand the concept very clearly. So let's start with this class today. So I am dividing the entire formulas into 4 groups. So first we will discuss group 1 formulas, then group 2, then group 3, then group 4. So what is group 1 formulas? See, first group formulas are, or we can also say properties of inverse trigonometry. You have studied that reciprocals of inverse trigonometric functions. What is the reciprocal of sine theta? As you know that it is reciprocal what? Cosec theta. So hence sine theta can be written as 1 upon cosec theta, vice versa. Similarly, reciprocal of tan theta is cot theta. Hence tan theta can be written as 1 upon cot theta. And similarly cosec theta, reciprocal of cosec theta is sec theta. So hence cosec theta written as sec theta and vice versa. So these were the fundamentals you have studied in trigonometry chapter of 10th standard. Now in the same manner the question may arise, is there any relation, inverse relation between the inverse trigonometric function? Of course yes. How? See, the first inverse relation we are writing sine inverse of x can written as cosec inverse of 1 upon x. I repeat, sine inverse x can written as cosec inverse of 1 upon x. But while writing this expression, while using this property or while using this formula, remember sine, you have started with sine inverse x. So x must be belongs to its domain. What is the domain of sine inverse x? We have already studied. This lies between what? Minus 1 to 1. Are you getting? So we are speaking the formula of sine inverse x. Hence the x, whatever the value here, it must be belongs to its domain. So I can also speak the same one here by reversing the ratios. Cosec inverse of x can written as sine inverse of x. By speaking this, we have started with cosec inverse of x. Hence, x must be belongs to domain of cosec inverse x. And what is the domain of cosec inverse x? That is entire real number except minus 1 to 1 range. So these are the reciprocals. Now see here, sine inverse x can written as cosec inverse 1 by x, cosec inverse x written as sine inverse x. While writing these formulas, have you observed one common thing? We are reciprocaling the value of x only, not the entire one. So we can also observe that sine inverse x doesn't mean that it's sine x whole inverse, remember. So ultimately sine inverse x, it doesn't mean that simply 1 by cosec inverse x. So it cannot be equal to 1 by cosec inverse x. Remember my friends, sine inverse x cannot be written as 1 upon cosec inverse x as we are writing in sine trigonometric function sin theta is 1 by cosec theta. We cannot follow the same in the inverse trigonometry. Their properties are different. Now I am going to prove how sin inverse x will be cosec inverse 1 by x, how cosec inverse x will be sin inverse x. Let's see the derivation first short. Right. So while speaking this property, we have to remember it following the domain of the sin inverse x, and hence x must be equal belongs to -1 to 1. Now we are going to see the proof of this property. Now see, what is the left hand side we have? Left hand side we have sin inverse x, correct? So now to simplify further, to get in terms of cosec theta, what I am assuming here, because we are having sin inverse function, hence I am assuming x is equal to sin theta. If it is cos inverse, I will assume cos theta. If it is tan inverse, I will assume tan theta. It's a traditional method to prove any properties of inverse trigonometric functions. Now if I take x is equal to sin theta, so definitely what we will say, sin inverse of sin theta, and it becomes a property. Sin inverse of sin theta is theta. And what is meant by theta now? What we are started with? We have started with like x is equal to sin theta. So theta will be sin inverse x. Hence theta will be what we called as sin inverse x. Okay, just a minute. So we have solved the left hand portion. We got it as theta. So this is what the left hand portion, and what is the right hand portion here? RHS. Now see, we have cosec inverse of 1 by x. So in the same manner, what we are assumed, x is equal to sin theta. Then substitute sin theta in the RHS part. Are we going to get the same result or not? So let's see. Cosec inverse of 1 upon sin theta. So as you know, 1 by sin theta can written as cosec theta. And you know that cosec inverse of cosec x is x. Hence, cosec inverse of cosec theta will be theta. So now you got it as what? LHS is equal to RHS. So I hope you have understood how sin inverse x can be cosec inverse of 1 by x. Cosec inverse x can be sin inverse of 1 by x. So this is a property. In this manner, you may prove the subsequent properties. Means simply to prove any property, if you have sin inverse as a function, then take x is equal to sin theta, then substitute that sin theta in left hand side as well as right hand side to prove any identity or a property. Is the simplest way to prove a property. Now in this manner, now I can list all the formulas here, okay, as a first part of the formulas. So in this manner, I can simply write the formulas. In short, sin inverse x can written as cosec inverse of 1 by x. While speaking this, x must be belongs to -1 to 1 because we are dealing with the domain of sin inverse x. Similarly, what we will say, cosec inverse x can written as sin inverse of 1 by x, where x is belongs to any real number except -1 to 1 as the domain of cosec inverse x. In a similar manner, you can also speak for cos and sec. Cos inverse x is written as what? Sec inverse of 1 by x, where x is belongs to -1 to 1. Then sec inverse x can written as cos inverse 1 by x, where x is belongs to any real number except -1 to 1. But when you talk about tan and cot relation, there are little bit conditions you need to follow, and more specifically, see, if I say cot inverse x, then there are two possibilities of this conversion. Cot inverse x can be written as tan inverse of 1 by x, right? So while speaking this, what you will say, x must be greater than 0. But what else if x is less than 0? When x is negative, then formula becomes pi plus tan inverse of 1 by x. Reason behind this is to maintain the domain and the range, that is principal range of the inverse trigonometric functions. That's why while applying this cot inverse x formulas, you need to focus the value of x involved. If x is positive, you can simply convert them into tan inverse of 1 by x. If x is negative, then you have to use this pi plus tan inverse 1 by x. Nothing else, very simple to remember. Just you need to follow the condition before apply the formula. Similar manner, when you are converting tan inverse x in terms of cot, you can write it as cot inverse 1 by x, where again x is greater than 0, and where x is less than 0, it will be as minus pi plus cot inverse of 1 by x. So this is the first set of formulas we have discussed. Also, we have already discussed the derivation for the first part. In the similar manner, you can prove each and every property by taking x as a corresponding t ratio. If you are dealing with cosec inverse x, let us assume x is equal to cosec theta. If you are dealing with cos inverse x, take x as cos theta. In similar manner, cot inverse x, let's take x is equal to cot theta. So this is a fundamental way to prove any property of inverse trigonometric ratios or inverse trigonometric functions. So this is the first part. You need to remember these formulas because we are going to use these formulas thoroughly while doing the questions. Okay, so let's have a discussion on the second set of formulas. Yes. So before start the second set of formulas, I wanted to recall you all, and you know very well that in 10th standard, in 11th standard, you have studied that there are three major identities you are using. Sine square theta plus cos square theta equal to 1. Right? Is a famous identity. And then sec square theta minus tan square theta is also equal to 1. Cosec square theta minus cot square theta is equal to 1. So these are the three identities you have used in 10th standard. So similarly, when we are dealing with inverse trigonometric function, so inverse trigonometric function also, this sine inverse x and cos inverse x are related. Sec inverse x and tan inverse x are related. Cosec inverse x and cot inverse x is also related. How they are related? Now see, and how it can be possible. The first relation between sine and cos is sine inverse x plus cos inverse x is equal to pi by 2. This is the first relation between the sine and the cos. How it can be possible? Because sine inverse x and cos inverse x have the same domain. So if you have remembered the domain of these two functions, the domain of this function x is belongs to minus 1 to 1 only. Hence, the relation between these two inverse trigonometric ratios are possible. Now, we are going to prove how this property will work. So, to simply understand the concept, again the same way I am going to do. If it is sine inverse x, I will assume x as sine theta. Question may arise, sir, we also have cos inverse x. Shall we take cos theta also? Yes, definitely you will go with cos theta, you will go with sin theta. So there is no issue between these two statements. So I am here taking x as sin theta to prove this statement. So I am taking the left hand side of this. So in a LHS part, I am assuming put x is equal to sin theta. So the expression now becomes sin inverse of sin theta plus cos inverse of cos theta. So similarly, sin inverse of sin theta is what? Theta only. But to reduce, we have taken this as sin theta, so it should be sin theta. Now, we cannot reduce this expression until and unless this converted into cos theta. And you know that how can we convert sin theta in terms of cos? You know that sin theta can be written as cos pi by 2 minus theta. Sin theta can be written as cos 90 minus theta. So in a similar manner, I am reducing cos inverse of sin theta can be written as cos of 90 minus theta. Fine. Now it in the form of exact property. Cos inverse of cos x is x. So in similar manner, theta plus, the answer would be what? Pi by 2 minus theta. So plus theta minus theta get cancelled. Answer would be pi by 2. So I hope you have understood how this property can work. So sin inverse x plus cos inverse x is always equal to pi by 2. In a similar manner, you may also prove other two properties in the same head. Okay, let's see what are the other two. Now I am writing the rest of the properties. We have under this head, we have three formulas. Here are three properties we have. First one is sin inverse x plus cos inverse x is pi by 2, where x is belongs to minus 1 to 1. And the second one is tan inverse x plus cot inverse x is also equal to pi by 2. Reason again, x is belongs to real number which is a common domain of tan inverse x and cot inverse x. These two have the common domain. Hence the relation can be established. Same way, how to prove? By assuming x as tan theta. Substitute tan theta here, then it is reduced to pi by 2, as we have discussed the case in the first one. And the third one, the last one, you have understood remaining t ratios are sec and cosec. So sec inverse x plus cosec inverse x is equal to pi by 2, where x is belongs to every real number except minus 1 to 1, open bracket. So these are the second set of formulas. So I hope you have understood the first set of formulas and second set of formulas here. The first one were related to reciprocal, second one is related to what? Having the common domain. Inverse trigonometric ratios having the common domain. So here sin inverse x and cos inverse x have the common domain, hence this relation can possible. Their addition will give pi by 2. Similarly, tan inverse x and cot inverse x have the common domain, hence their sum is always give pi by 2. Sec inverse x plus cosec inverse x have the common domain, hence their sum is always give pi by 2. So these are the second set of formulas. Now we are going to discuss the third set of formulas. See how the formulas will be. In the third set, we have various formulas which are very helpful, very useful while dealing with the questions, and we are going to use these formulas very frequently. So you have to be very thorough in the formulas. Right. The third set is what? It's simply the sum or a sum or a difference of same trigonometric functions, inverse trigonometric functions. What does it mean? You have studied that sine of a plus b will be written as sine a, that is sum of the two angles or difference of two angles can be written as sine a into cos b plus cos a into sine b. So in a similar manner, in inverse trigonometry we are having formula like sine inverse x plus sine inverse y. I repeat, sine inverse x plus sine, sum of the two inverse trigonometric function of same kind can written as sine inverse of x into under root 1 minus y square plus y into under root of 1 minus x square. It seems like difficult expression, but I'm sure while applying this identity you will feel the easiness in the simplification part. So don't bother about the this expression, because just while simplifying the questions, so if you are recalling these formulas again and again, so it becomes easy to remember. Okay, only the practice is required. So sine inverse x plus sine inverse y will be equal to sine inverse of x into under root 1 minus y square plus y into under root of 1 minus x square. To prove this, again the same way as I told you to prove any properties in the inverse trigonometric functions chapter, simply you need to assume some value of x and y in terms of trigonometric ratios. Here we are having both are sine inverse, so x and y should be equal to sine theta only, but x and y are two different variables. That's why we are taking x as sine theta, y as sine alpha, nothing else. Okay, so we are substituting these two values in the left hand side and right hand side. If you are able to get the same answer, means this property is verified. So I am just discussing one proof for your reference. X is equal to sine theta and y is equal to sine alpha. So definitely what you will get then, sine inverse of left hand side I am solving, sine inverse of sine theta plus sine inverse of sine alpha. So it becomes a property, sine inverse of sine theta is theta, sine inverse of sine alpha is alpha. So this is LHS part. Now what else for RHS part? Same way, x should be sine theta, y should be sine alpha. If you substitute that, what you will get? Here it will be sine theta into under root of 1 minus sine square alpha plus sine alpha into under root of 1 minus sine square theta. So in the next step you can simply simplify this one. 1 minus sine square alpha is cos square alpha. Cos square alpha and square root get cancelled, you will get cos alpha. So finally you will get what? Sine theta into cos alpha. Similar mannerly you can also say sine alpha and it reduced to cos theta. So if you observe this one, it becomes just like this identity. Sine a cos b plus cos a sine b written as sine of a plus b. So sine theta cos alpha plus cos theta sine alpha can written as sine of alpha plus theta or theta plus alpha, whatever you want. Addition is always commutative. So hence the reduced answer would be sine inverse of sine x is x. Hence answer would be theta plus alpha. So you got LHS is equal to RHS. Hence this property is verified. So friends, you have understood how the property can be verified or can be proven simply by assuming the value of x and y with the corresponding t ratios. Hence, once you solve the left hand side and right hand side, if you are arriving the same result, it means that it is proven. So in a similar manner, I am going to list out few formulas which comes under this head. Okay, simply now I am changing. This is what sum of the two t ratios. If it is a difference, if it is a difference, means sin inverse x minus sin inverse y, the only formula will remain same, only one sign will change, that is the middlemost sign, nothing else. So that's why I am marking here with a red pen, so that you can easily identify. If it is a plus sign, it will be plus in between. If it is a difference of these two ratios, it means the difference will come. Only the corresponding sign, rest expression is remain same, derivation will also remain same. So as we have discussed in terms of sign, you may also discuss for cos inverse x plus cos inverse y. So here without proof I am writing the next properties, which because they are very similar, these proofs you can do yourself. Fine. So I am writing the next property here. Which one? Cos inverse x plus cos inverse y. How can we? Cos inverse x plus cos inverse y is written as cos inverse of x into y minus under root of 1 minus x square into under root of 1 minus y square. See, if you observe the same one is as sign, we have discussed this one. So in a similar manner, you may also prove for cos inverse x plus cos inverse y simply by assuming x as cos theta, y as cos alpha. Put those values in the left hand side and right hand side, you will get the same answer, hence it can be proved. So now if you observe the sign, if it is sum of the cos inverse, the middlemost sign is negative. What else if it is negative? Then it will be positive. Opposite sign will follow while dealing with cos inverse formulas. But in sin inverse formulas, same sign will be followed. So in a similar category, I can also write for tan inverse x and tan inverse y. So before going to the tan inverse x plus tan inverse y, I want to recall again the point you need to remember, that while dealing with sin inverse x plus sin inverse y, some are difference, same sign will go here. But while dealing with cos inverse, opposite sign go here. Okay. So now let's have a discussion on tan inverse x plus tan inverse y. These all are coming under the third, because we are dealing with sum or difference of inverse trigonometric ratios. Now what we have, see, tan inverse x plus tan inverse y, tan inverse x plus tan inverse y. Here, while applying these formulas, we have to very careful about the value of x and y. Why? Because there are three cases arise while applying these formulas, depending on the nature of x and y. Now it is simply reduced to tan inverse of single t ratio as x plus y upon 1 minus xy, right? It will work only when product of these two values is greater than 1. I repeat, this formula is only works where the product of given two values is greater than 1. That's it. And what else if xy is less than 1? So product is less than 1 means either here, see, sorry, here one mistake. Now see, the product must be here less than 1. This formula only will work when the product of the two variable is less than 1. What else if xy is greater than 1? And you know, product of two numbers is greater than 1 means either x and y both are positive or both are negative. So plus into plus is plus, minus into minus is also plus. Means when product is greater than 1, there are two cases arise. I repeat, when product is greater than 1, there are two cases arise. So one is where x and y both are positive, means x greater than 0, y greater than 0. Here x less than 0, y less than 0. So hence this formula can be written in a three different forms based on x and y. So here simply the core part will be same. Some parts are added to this main core formulas. So it is easy to remember, easy to apply well. So the second one will work when this are possible. Pi plus tan inverse of x plus y upon 1 minus xy, and here minus pi plus tan inverse of x plus y upon 1 minus xy. If you observe these formulas, the core part is same, only here it's a pure tan inverse x plus y upon 1 minus xy. Here pi plus this formula minus pi plus this formula. Only these two things are added according to the value of x and y. So what the learning point from this discussion is, before apply these formulas into a solution, you need to check the condition they are following. See what is x and what is y first, and then go for this condition. Whether the product is less than 1, whether the product is greater than 1. If greater than 1, is x and y positive or x and y negative? Once you study the nature of x and y, you can easily apply the specific formula to reduce the expression. So this is the sum of the tan inverse x and tan inverse y. In a similar manner, you may also discuss the difference of tan inverse x minus tan inverse y. But I cannot say that by simply changing one sign, by changing somewhere else you are going to get. No. In tan case, it's a different set of formulas. So that's why again I am writing the tan inverse x minus tan inverse y in a three different situations. Okay. So let's see. So now we are discussing here tan inverse x minus tan inverse x. So difference of t ratios, inverse t ratios. Again there are three cases arise. The first one is a general one, that is tan inverse of x minus y upon 1 plus xy. 1 plus xy, right? And the second one is pi plus tan inverse x by x minus y by 1 plus xy. Third is minus pi plus tan inverse of x minus y by 1 plus xy. So here, if you have observed this, these three conditions arise again based on x and y nature. So if the product, first we'll check the product. The product of x into y is greater than minus 1. If the product is greater than minus 1, this formula can be applicable. And if xy, the product is less than minus 1, but it is only possible one is positive, other is negative. So that's why again when the product is less than minus 1, there are two cases arise. This will only work when x is positive, y is negative. I repeat, x is positive, y is negative. It cannot be 0. Similarly, if x is negative and y is positive. So friends, so simple, you need to remember these formulas to apply in the questions, but before applying to the questions, simply you need to check the nature of x and y. First we'll take the product of x and y. Is the product is greater than minus 1 or less than minus 1? If it is greater than minus 1, simply apply this formula. If it is less than minus 1, then check whether x is positive or y is positive. If you are following this condition, your answer will be accurate and there is no chance to get a wrong answer. Okay, so in this way we have discussed sin inverse x plus sin inverse y, cos inverse x plus cos inverse y, tan inverse x plus tan inverse y, plus as well as minus. Now the sum and the difference of the inverse t ratios are over. Now we are getting to the fourth part of the formulas. That is a very short one. So among these four parts, the third part was little bit lengthy. Reason, there are several cases involved. Okay. Now the fourth and the last part of this chapter. Now what is the fourth part we have? So there are very interesting formulas we have like tan 2 theta formulas, right? So tan 2 theta can written as 2 tan theta by 1 minus tan square theta, correct? In a similar manner, you may also write sine 2 theta, cos 2 theta, in terms of tan only. In terms of tan I am speaking. Sine 2 theta can written as here 2 tan theta by 1 plus tan square theta. By simplifying this expression, you will get sine 2 theta. Cos 2 theta can written as 1 minus tan square theta by 1 plus tan square theta. So these are the formulas we have studied in 11th standard. Now in a similar manner, as we have here 2 theta formulas, here also we are having 2 times of tan inverse x formula, 2 times of tan inverse x formulas here. See, very useful formula it is, 2 times of tan inverse x. So now this can be written in three various forms as sine, cos, tan. All are can be expressible in terms of tan. Similarly, tan inverse x can expressible in terms of sine, cos and tan. Hence, 2 tan inverse x formulas can be written in three different forms, right? So first I am expressing in terms of sine. In terms of sine, it can be as sine inverse of 2x upon 1 plus x square. In the same manner, I can also written the same inverse function in terms of cos inverse, simply by writing 1 minus x square by 1 plus x square. And in terms of tan, that is tan inverse of 2x by 1 minus x square. So these are the three set of formulas, means I can convert to tan inverse x as per the requirement. I can convert this into sine inverse, cos inverse, tan inverse. But while converting, again you need to remember the x, value of x which is involved in the expression lies between -1 to +1. Here also in terms of here -1 into x into 1. But here when you say it is x is greater than 0 or equal to 0. So while you are speaking here, the condition should be followed, but in most of the cases there are simply you can apply the formula without looking into the condition, it may work. But in 10% sums in a boards, they are twisting the questions based on the condition, nothing else. 90% sum, when you go through the NCERT, when you go through the any of the reference, general sums are based on the single and standard formulas. But when the questions are twisted, they are just playing the games based on the condition involved. If the student ignore the condition, so they may get into the wrong formulas. Based on that, they may get the wrong conclusion. So their entire hard work will get into the what we can say, that is there is no result of that efforts. So fine, so these are the formulas you need to remember. There are several formulas, you just like 2 tan inverse x written as in 3 different forms. Similarly 2 sin inverse x you can written as 2 cos inverse x, but that is not required. Reason is we are going to learn how to convert one t ratio into other t ratio. Simple. That is the last part of this video lecture here. So now how can we convert that into C? Okay. Now there's the last part need to be discussed here. See, right. So sine inverse x is there. So you may written as it as cosec inverse of 1 by x as reciprocal speaks. You may also retain this sine inverse x in terms of cos, tan, cosec, other 5 t ratios. Why? How? If you are speaking this sine inverse x, what does it mean? Here sine inverse of this x can be what? Sine theta. If I assume x is equal to sine theta, so if I assume x is equal to sine theta, so what we can say here, sine theta will be x by 1. Then if I assume x is equal to sine theta, what sine theta will be x by 1, which means that in a right angle triangle where base angle is theta, this is perpendicular, this is hypotenuse, this is perpendicular, this is hypotenuse. I can get the base as under root of 1 minus x square by using Pythagoras. Now if I know the 3 sides, I can simply find other t ratios, right? Means sine inverse x can be converted into other t ratios. Simply how? Cos inverse of base upon hypotenuse. So under root of 1 minus x square upon 1, noted upon 1. Hence sine inverse x can also written as cos inverse of 1 minus x square. Similarly, I can also write sine inverse x as tan inverse of p by b, x upon under root 1 minus x square. Can also written as sec inverse of hypotenuse upon base, that is 1 upon under root of 1 minus x square. It also written as cot inverse of under root 1 minus x square by x. It means that what? If you have one inverse t ratio, you may convert this in one inverse t ratio into other 5 t ratios as per the requirement. So you may also convert one inverse t ratio into other inverse t ratio simply by taking the help of right angled triangle, because one value is there, means by writing upon 1 you are able to get 2 sides of right angled triangle. By applying Pythagoras theorem you will get third side. Once you know the 3 sides, you may convert one inverse t ratio into other 5 t inverse t ratios. It is a very simplest manner to convert one to other. So if you forgot the formula of sine inverse x plus sine inverse y, so no need to worry, because sine inverse x plus sine inverse y can convert into tan inverse x plus tan inverse y. You can go with that formula. For example, if you forgot cos inverse x plus cos inverse y, no need to worry, because you know that cos inverse x and cos inverse y both can be converted into tan inverse x plus tan inverse y. Hence tan inverse x plus tan inverse y formula can also work. So it is just art of converting one t ratio to other t ratio. If you are able to convert in this way, so only one set of formula will also work. So that's why most of the people are using tan inverse x plus tan inverse y instead of sin inverse x plus sin inverse y and cos inverse x plus cos inverse y. So this is my suggestion also, कि better to use tan inverse x plus tan inverse y or tan inverse x minus tan inverse y formulas rather than sin inverse x plus sin inverse y and cos inverse x plus cos inverse y. Until and unless it is mandatory to use, or until and unless it is necessary to use. Okay, so apart from these all formulas, just sometimes we need to simplify the questions. We need to substitute, we need to have one skill that we called as substitution method. So sometimes, just like what we say in general, we have observed in the entire video, in each and every formula, so right, to prove that formulas I am using substitution method. Substitution method. If it is sin inverse x, I am taking x is equal to sin theta. If it is cos inverse x formula, I am using x as cos theta. So it is a simple technique to prove an identity, to prove a property of inverse trigonometry. In a similar manner, if some expressions are involved, so some substitutions will work. So that is what I am going to list out for your reference. And while doing the sums, I will take this formulas wherever it is necessary, wherever it is required. Okay, see what are the expressions involved and what substitution will work. So if the expression, just it is in what we called as, need to remember when you wanted to do the sum with the substitution method. So you might have get into the confusion that what to be taken. So that's why we are listing few expressions here and suitable t ratios. So if it is expression and the suitable t ratio you need to put. If the expression is involved, like some a square minus x square or under root of a square minus x square, if the expression is involved in this form, then take the substitution x is equal to either a sin theta or a cos theta. Why I am using? If I substitute this expression is reduced to a simplest form. See, if I substitute x is equal to a sin theta, what it becomes? A square minus a square sin theta. So a square will be common. 1 minus sin square theta become cos square theta. So the entire expression becomes what? A square cos square theta. So this is a way of reducing, a way of simplifying the expression with the help of proper substitution. Okay, for that I am listing few expressions which are frequently coming in the questions where you are able to substitute the value of x. So now I am writing the next one. If the expression involved where x is a variable, a is a constant, remember, then x square minus a square or under root of x square minus a square. Here x will be a cosec theta, or a cot theta, a cosec theta, a cot theta. Now you have understood the way I am using here. The third expression, if the addition of these two variables are there, like under root of x square plus a square, then we'll go for the x is equal to a tan theta or a cot theta. So these are the fundamentals expressions where we need to go with the substitution method. So while using the substitution method, the specific t ratio will work. Now in a similar manner, if the expression is involved, like fourth one, a plus x upon a minus x or vice versa, or the expression is in the form of a minus x upon a plus x. In both the cases, we will substitute a is equal to a cos 2 theta. Remember, a cos 2 theta will reduce the expression into simplest form. Now the fifth one is, if it is in the form of a square plus x square by a square minus x square or under root of a square minus x square by a square plus x square, then x is equal to a square, a cos 2 theta, a cos 2 theta. See, x square is equal to a square cos 2 theta. I am repeating here, it's a very important to remember this expression, because wherever these expressions are involved, very carefully you need to select the t ratio to reduce the form. So when the expression in the form of this, we will assume x square is equal to a square cos 2 theta. If you take this suitable substitutions, it is very easy to reduce it. And the last expression I am writing, so here the last expression, is if it in the form of like x upon a plus x or a plus x upon x. In both the cases, we will presume x is equal to a tan square theta or a sec square theta. Remember, either I will go with a tan square theta, either I will go with a sec square theta. We'll reduce this entire expression to make the simplification easy. So this is the way you need to remember. These all set of formulas I have covered in this video, and the entire set of formulas I am going to provide you in the form of the PDF file. So no need to worry if you missed out something. So everything is very clearly mentioned in the sheet. So before getting to the next session, where we are going to discuss the few important sums which are related to these formulas and the properties, I request you all to go through this video thoroughly, and before coming into the next session, please by heart this all formulas. So as when you just remember these formulas, when you go through this and when you thorough in the formulas, it is very easy to solve the questions. Solving the questions is just a बोलते हैं ना इन हैंडी, एक हमारी बाई हाथ की खेल होती है. सिर्फ फॉर्मूला एक गेम है. अगर आप फॉर्मूले को थरोली याद रखें along with the condition, and this chapter will be a beautiful chapter for you. Otherwise it's going to be a hell for you. It's completely in your hands whether you are interested to learn it or by heart it or understand it. Okay, so thank you, and keep watching these next subsequent videos to understand the importance of these formulas to reduce the questions. Thank you, take care, and take care yourself.